Something is happening in our solar system that doesn't match any model we've built, and the scientific community is scrambling to figure out why. October 15, 2025. Observatories across 3 continents recorded the same anomaly. Comet C 2023, A3, better known as Tsuchinshan Atlas, suddenly brightened by 4 magnitudes in less than 72 hours. That's a 16-fold increase in luminosity. In comet behavior, that's the equivalent of a sleeping dragon suddenly opening its eyes. But here's what makes this truly bizarre. It happened at completely the wrong distance from the sun. Let me explain what comets are supposed to do. As they approach our star, solar radiation heats their icy surfaces, causing frozen gases to sublimate, transitioning directly from solid to gas without becoming liquid. This creates the iconic tail we associate with comets. The process is predictable, mathematical, boring in its consistency. We've observed thousands of comets. We know the script. C 2023. A 3 just tore up that script. The brightening event occurred at approximately 1.8 astronomical units from the sun. That's roughly 270 million kilometers away. At this distance, solar heating should be relatively gentle, producing steady, gradual brightening as volatile materials slowly cook off the surface. What we witnessed, instead, resembled an ignition switch being flipped. Within the astrophysics community, 3 competing theories emerged almost immediately, and none of them are comforting. Theory 1. Subsurface explosive outgassing. Imagine pockets of highly volatile materials, perhaps carbon monoxide or carbon dioxide, ice trapped beneath an insulating crust. As the comet slowly warms, pressure builds in these subsurface chambers until the crust fractures catastrophically, releasing massive gas jets in explosive bursts. We've seen this before with comets like 17P Holmes, which brightened by 500,000 times in 2007. But here's the problem. 17P Holmes erupted at 2.4 astronomical units from the sun, and its outburst was a singular event. C 2023, a 3 has now experienced 3 separate brightening episodes over 6 weeks. That suggests something more complex than simple pressure release. Theory 2, rotation-induced structural collapse. Comets aren't solid rocks. They're loosely bound aggregates of ice, dust, and rocky material, held together by weak gravity and frozen volatiles. As solar heating increases, these structural bonds weaken. If the comet is rotating rapidly, centrifugal forces could literally tear chunks off the surface, exposing fresh, volatile-rich material that immediately vaporizes in sunlight. Spectroscopic analysis from the Southern African Large Telescope captured something extraordinary on October 18th. The comet's spectrum showed sudden spikes in cyanogen and diatomic carbon emissions molecules that typically remain locked in pristine ice deep within a comet's interior. Seeing them in such abundance suggests we're witnessing freshly exposed material supporting the structural collapse hypothesis. But theory 3 is where things get genuinely strange. Several researchers are proposing that C 2023 A3 might have an unusually high concentration of amorphous ice, a disordered, non-crystalline form of frozen water that traps other volatile molecules within its structure. When amorphous ice transitions to crystalline ice, it releases energy and simultaneously frees trapped gases. This phase transition can occur suddenly when specific temperature thresholds are crossed, potentially explaining the switch-like activation we observed. Here's why that matters. If C 2023 A3 contains substantial amorphous ice, it's providing us a glimpse into the pristine conditions of the early solar system 4.6 billion years ago. Amorphous ice forms in extremely cold environments. We're talking temperatures below minus 230 degrees Celsius. This comet might be a frozen time capsule, preserving materials and conditions from the solar system's birth. But the mystery deepens. On October 21st, radio telescopes at the Atacama Large Millimeter Array detected unexpected emissions from C 2023, a 3's coma, the cloud of gas and dust surrounding its nucleus. The signal showed molecular signatures inconsistent with standard comet chemistry. Specifically, they found complex organic molecules, including formaldehyde, methanol, and possibly ethanol, in concentrations far exceeding predictions. Why does this matter? These organic molecules are precursors to biological chemistry. Their presence in high concentrations suggests C-2023 A3 might have formed in a molecular cloud rich in organic chemistry, or alternatively, that chemical processes within the comet itself have been synthesizing these compounds over millions of years. Dr. Sarah Chen from MIT's Planetary Science Department told reporters something remarkable. We're not just observing ice and rock. We're observing a chemical factory that's been dormant for potentially millions of years, and solar radiation just turned on the power. Now let's talk about what happens next, because this is where predictions become genuinely difficult. C-2023, a 3 reaches perihelion, its closest approach to the Sun on October 29th at 0.39 astronomical units. That's inside Mercury's orbit. Solar radiation intensity at that distance is roughly 6 times stronger than Earth experiences. If the comet has been this active at 1.8 astronomical units, what happens when heating increases 6-fold? 3 scenarios exist, ranging from spectacular to catastrophic. Scenario 1, sustained outgassing. The comet continues releasing material in controlled bursts, creating a magnificent tail visible from Earth with the naked eye throughout November. This would make C-2023 A3 one of the brightest comets of the 21st century, potentially reaching magnitude 2 or brighter, rivaling the brightest stars in the night sky. Scenario 2, complete disintegration. The structural stresses from rapid outgassing combined with extreme temperature gradients cause the nucleus to fragment into multiple pieces. We've witnessed this before with comets like C-1999 S4 Linear, which broke apart into dozens of fragments during its perihelion passage in July 2000. If C-2023A, 3 fragments, we'd essentially be watching a slow-motion demolition derby as individual pieces follow slightly different orbits, each creating its own tail. Scenario 3, dormancy. Here's the counterintuitive possibility the comet might actually dim. If explosive outgassing has expelled most of the volatile surface material, exposing a non-volatile rocky crust, solar heating at perihelion might not have much left to vaporize. The comet could paradoxically become less active precisely when it should be most active. Early observational data from November 1st is already providing clues, and frankly, it's not matching any of our scenarios cleanly. Ground-based observations show the comet has maintained brightness around magnitude 4 easily visible with binoculars, challenging with naked eye from urban locations. The tail has extended to approximately 15 degrees across the sky, creating a spectacular visual display. But spectroscopic monitoring reveals something unexpected. The chemical composition of the tail is changing day by day. On October 27th, the dominant emission was from sodium, giving the tail a distinctive yellowish tint. By October 30th, calcium emissions dominated, shifting the color toward orange. By November 2nd, we're seeing strong magnesium lines. This sequential variation suggests we're watching layers of the comet peel away like an onion, each layer having distinct chemical composition reflecting different formation conditions billions of years ago. Dr. James Morrison from the European Southern Observatory described it this way. Imagine opening a book where each page was written in a different era. That's what we're reading in this comet's chemistry, a chronological record of solar system history revealed one layer at a time. But here's the detail that's genuinely puzzling astronomers. On November 4th, multiple observatories detected what appears to be a secondary nucleus, a distinct condensation in the coma located approximately 10,000 kilometers from the primary nucleus. This could represent a fragment that separated during one of the explosive outbursts, or potentially, it could be revealing that C-2023, a 3 was always a binary system, 2 objects orbiting each other, only becoming distinguishable when outgassing created enough separation. Binary comets are extraordinarily rare. We've only confirmed a handful in astronomical history. If C-2023A3 is indeed binary, it raises profound questions about its formation. Did two separate objects capture each other gravitationally millions of years ago? Or did a single parent body split during a previous perihelion passage, perhaps centuries ago, with the fragments remaining loosely bound? The gravitational dynamics of a binary comet approaching the Sun are complex. Tidal forces from solar gravity combined with asymmetric outgassing can either pull the components apart or push them together. Over the next 3 weeks, we'll discover which fate awaits C-2023-A3. Now, let me address the elephant in the room. Could this comet pose any danger to Earth? The answer is definitively no. C-2023-A3's orbit is well characterized. Its closest approach to Earth occurred on October 12th at 0.47 astronomical units, roughly 70 million kilometers. That's about half the distance to the Sun, and in astronomical terms, it's not particularly close. The comet is now receding from both Earth and the Sun, following a hyperbolic trajectory that will eventually eject it from the inner solar system entirely. However, and this is fascinating, orbital calculations suggest C-2023-A3 might be an interstellar visitor. Its orbital eccentricity, a measure of how elongated its orbit is, appears to exceed 1.0, which mathematically means it's not gravitationally bound to the Sun. Like Oumuamua in 2017 and comet Tuai-Borisov in 2019, this might be our third confirmed interstellar object passing through our solar system. If true, this transforms the scientific significance entirely. We're not just studying a comet, we're studying chemistry and physics from another star system, possibly from a stellar environment completely unlike our own. The unusual activation behavior, the unexpected chemical signatures, the potential binary nature, all of these oddities might reflect formation conditions in an alien planetary system. Dr. Rachel Foster from Caltech summarized it perfectly. Every comet we've studied previously formed in our solar system. There are siblings. If C-2023-A3 is interstellar, it's a visitor from another family, bringing news from a neighborhood we've never sampled before. So where does this leave us? As of November 10th, C-2023-A3 remains active, visible, and deeply mysterious. Professional observatories worldwide are dedicating telescope time to continuous monitoring. Amateur astronomers are contributing thousands of observations through coordinated networks. Space-based assets, including the Solar and Heliospheric Observatory and the James Webb Space Telescope, have scheduled observation windows. We're collectively gathering the most comprehensive data set ever assembled for a single comet. And yet, fundamental questions remain unanswered. What triggered the activation? Why the sequential chemical variations? Is it truly binary? Is it interstellar? Will it survive perihelion intact? These aren't academic curiosities. Understanding comet behavior has direct implications for planetary defense. Knowing how these objects respond to solar heating helps us predict the behavior of potentially hazardous comets in the future. Understanding their chemistry informs theories about how water and organic molecules were delivered to early Earth, possibly enabling the emergence of life. Understanding their structure helps us model the conditions in the primordial solar nebula 4.6 billion years ago. C-2023. A3 is teaching us lessons we didn't know we needed to learn. Here's my challenge to you. Go outside in the next few weeks. Find a location with dark skies, away from city lights. Look toward the western horizon after sunset. You might see it, a fuzzy streak against the stellar background, perhaps visible even without optical aid if you're lucky. That fuzzy streak is a visitor from either the outer solar system or possibly from interstellar space, revealing its secrets as solar fire strips away layers accumulated over billions of years. You're witnessing cosmic archaeology in real time. The data will take months to fully analyze. Papers will be written. Theories will be refined or discarded. But right now, in this moment, We have the privilege of watching nature conduct an experiment we couldn't replicate in any laboratory. An experiment in high-energy physics, chemistry, and dynamics played out across millions of kilometers of space. C 2023, a 3 has activated something we don't fully understand yet. But that's not a failure of science, that's an invitation. An invitation to look closer, think harder, and remain humble before the cosmos's infinite capacity to surprise us. The comet will fade from view by December, retreating into the outer solar system or beyond, carrying its remaining secrets with it. But the questions it raised will occupy researchers for years to come. And perhaps that's the greatest gift any cosmic visitor can provide. Not answers, but better questions. Stay curious. Keep watching. The universe is speaking. We just need to listen carefully. So let me ask you this. Do you think comets like C 2023, a 3, are just frozen rocks? Or could they be the universe's way of spreading the seeds of life across the cosmos? Drop your thoughts in the comments below. I genuinely want to know what you think about this. And if you found this deep dive into cosmic mysteries valuable, hit that like button. It genuinely helps this content reach more curious minds like yours. Subscribe if you want more stories about the universe's strangest phenomena, because trust me, C 2023, a 3 is just the beginning. We're living in an era where the cosmos is revealing secrets faster than ever before, and I'll be here breaking down each discovery as it happens. The universe is speaking. We just need to listen carefully. And I'll see you in the next one.